Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our reservoir engineering playlist and still about benchmarking recovery factors. And today's topic is about water cut versus recovery plot. I mean, water cut versus recovery factor plot. Okay, so again, these materials comes from this very good paper, benchmarking recovery factors for carbon reservoirs, key challenges and main findings from Middle Eastern fields. So you can find it and download it from One Petro. All right, so again, this topic is about water cut versus recovery factor plot, and the plot is here. This plot is a very simple diagnostic plot, all right, that will describe the reservoir performance, okay, which depend on development strategy and reservoir quality or reservoir properties. Okay, so by plotting water cut versus recovery factor, basically you can understand more about the reservoir performance and their relation to both the reservoir quality or reservoir properties and the development strategy. All right, and this plot, this very useful plot, can be generated for field level, all right, for reservoir level, even, within the same reservoir, you can create it also for cluster level, maybe pattern level, maybe segment level, or compartment level. Okay, so let's say you have one block, and within one block you have several fields, and you want to compare the performance of those fields. You can create this type of plot, water cut versus recovery factor. And let's say within the same field you have several reservoirs, and again within the same field you want to compare the performance of those reservoirs coming from the same field. Again, you can still use this type of plot to understand more about that field and those reservoirs. And within the reservoirs, within the same reservoirs, maybe you can have zonations, maybe you have compartmentalizations, maybe you have in water flood, you have clusters or patterns, okay? So you can compare the performance of those compartments within the reservoir, within the same reservoir. You can compare the performance of the clusters or the patterns within the same reservoirs, within the same reservoir. So you can rank them, you can understand more about the performance and again, their relation to the reservoir quality and development strategy. Okay, and in this paper, we can see here, we have this plot and you have, many entities here. Okay, and if you read the paper, these entities are reservoirs. So this plot will compare performances from several reservoirs in the Middle East. Okay, and you can see we can separate those reservoirs based on the performance of water cut versus recovery factor into 3 regions. Okay, and again, you can do it for reservoir level, block level, field level, cluster level, segment level, pattern, or compartment level, as long as you have the average water cut values with the associated recovery factor. Okay, so water cut at one time and recovery factor at that time. And you get water cut and recovery factor, and you can plot it like this. Okay, of course, as you continue producing, you will get more and more recovery factor. You will get higher recovery factor, but the water cut will increase as well. Okay, so you get the changes, you have the evolution of water cut as a function of recovery factor, and you can plot it like this. Okay, so within the paper you can read, this is a very informative thing for us. So if you have like this region 1, where you get rapidly increasing water cut, okay, with respect to recovery factor, you can include those performance into region 1. Okay, so basically you get water cut quite high within a very short period of time, which is not good. Okay, and you can have this type of performance in these types of reservoirs. So if you have poor rock quality, for example, okay, if you have tight reservoirs, if you have large transition zones or small thin oil columns, or if you have fractured reservoirs or karstified reservoirs connected to an aquifer, for example, basically you will get this type of performance in region 1. So you have rapidly increasing water cut with respect to recovery factor, okay, which is not good. But it's a given situation if you have the reservoir properties like this. If you have poor rock quality, tight reservoir, thin oil column, large transition zone, fractured or karstified, unfortunately, you will have, the risk of rapidly increasing water cut. But if you have good performance, you will get performance like this within the region 3. Okay, if you have, for example, good reservoir quality, good rock property, large reservoirs, and high oil columns, basically you will get performance like this region 3. So although you already have relatively high recovery factor, but the increase of water cut was a bit, low, was a bit slow. Okay, so yeah, this is a very good thing. You get more and more recovery factor, but the increase of water cut is rather slow. Okay, you can get that kind of performance in reservoir with good properties, large reservoirs, and of course, high oil columns, thick oil columns. All right, so you have region 1 and region 3, and basically the performance between region 1 and region 3 will lie within this region 2. So it's just like average performance. Okay, so again, this type of diagnostic plot is very informative. It's very simple. You just need the water cut data, recovery factor data, and then you have the zonations. You have the clear zonations, whether you want to make this plot for block level, field level, reservoir level, compartments level, okay, cluster level, or pattern level. Okay, so you get those data and then plot it like this, and you can see, and you can make 3 regions, okay, to distinguish region 1, region 2, region 3, to distinguish which reservoirs has performance like region 1, which has region 2 performance, and which has region 3 performance, where you will get, relatively low water cut, although you already have relatively high recovery factor. All right, so again, this is water cut versus recovery factor that is very useful to understand the reservoir performance, to categorize reservoir performance, and to do recovery factors benchmarking. All right, so I think that's all. I hope you enjoyed this video. I hope this video is informative and useful for all of us. And see you again in the next reservoir engineering playlist. Thank you.